Today's topic is actually, as you can see the title, so from labs and POCs to production. So a couple of hard lessons from more than 20 real-world AI projects. And as Diana mentioned, it's better to learn from others' mistakes than perform by yourself. So I hope that you will enjoy it and you will take out quite a lot of useful information here. To be honest, it might not be as technical a presentation, but we'll get into that in a moment. As a warm-up, though, you can ask the questions, but the first question today will be for you. So, how many IT projects do you think fail, like percentage-wise? Okay, so we have two answers, three answers. Everything is a little okay. So, guys, you are pretty pessimistic, right? As far as I can see. So, the most of the answers are like 10 out of like 9 out of 10. As I can see, there's one. The answer that just appeared that is the lowest is like, okay, 70-80%. Yeah, that's unfortunately those numbers are pretty high. Maybe not that high as like 90 or 95. It also depends on the reports. So this answer is actually compiled from like 2 or 3 reports by big companies like Accenture or Gartner, but or this chaos report that essentially analyzed a lot of enterprise projects. But it is 50 to 70, right? If we are talking like strictly we are right now telling strictly the IT projects. And within the IT projects, because someone already got into a Fortune report that is a little different. So there's one category of the IT projects that is distinctive, right? So those numbers are much different than this 50 to 70. And those are actually, this distinctive group is actually AI projects or data projects. So what do you think? Will this percentage be better or worse for them? Surely it must be better, right? Because, we have some Altman, right? Or the people from Anthropic telling us that, hey, the AGI is here, right? It will be there in like a month or just another model, right? And we'll have like the artificial general intelligence. So surely they must perform better, right? Well, not exactly, right? So even though the business trend is that, okay, let's use AI for everything, and it's that the business often thinks that, okay, it will solve every problem, the answer is that even more of the projects, like depending on the source, right? But it is clear that the pattern is that, okay, there are like IT projects as a benchmark, and then the AI ones are failing much more frequently, right? So at least 75%, 80% of them are actually failing. And today, we will try to, as mentioned, I will cover a couple of things in order to tell you how to avoid that. Because if you think about it, right, if you are sitting, in a room, right, or if this presentation would be on like a standard, like physical event, then you could take a look to your right, take a look to your left, and out of 5 people, like for the next 2 years, only one person would be working on something that does not go to the bin, right? That does not end being scrapped. And that's not exactly the brightest perspective, right? So as Diana mentioned, once again, I'm Michał Mikołajczak. Thank you guys for gathering here. And I've been working with the data and AI before it was cool, right? Before it was like LLM era or even like convolutional networks era. I've been in a couple of startups. I've been at big companies. Right now, I'm running my own agency when we are doing custom projects for AI and database, primarily for healthcare, but I've been working with, heavy industry. I've been working with legal. I've been working with churches. So I have quite a lot of broad range. And today I digested for you a couple of insights so that you can, become the people that if you apply those insights, you can either do as you were before, right, and is in this group that okay, these projects are ending in the bin, right, you would be frustrated and so on, or you can take the red pill today, and that would lead you to succeeding projects, happy users, glory, right. uh, as mentioned, I won't be focusing that much on like strict tech here, because one of the things that most of the courses and curriculums are doing wrong, if you take a look at that, so this is from one top university, like top three technical universities in Poland. I won't tell exactly which one, but if you look at that, those are the topics from curriculum, and there's only one distinct. There's one that is distinctive here, right? I don't know if someone can see that and want to point it in the chat, but there's one that is clearly different than the others. I don't see anything in chat. So the answer is like entrepreneurship, right? So there's one actual project on, like business, right? Or the project management for the whole 3 and 5 years of learning. So essentially, people are being taught very technical stuff, but this thing, tech is obviously very important, but it does not affect, and it affects the projects, right? But it's only a part. So, and in actual project, you have stakeholders, so you have end users, you have stakeholders that ultimately this AI algorithm that you are working on, they need to be using that, they need to be happy with it, and most of the courses are not taking that into account, right? And unfortunately, in today's times, I can tell you that the times when you can just sit in your cellar, right, and be the programmer that started to get into like computer science because he don't want to talk to people. Sorry, those time are gone. So unfortunately, you need to be aware of the business. You need to be aware what you are working towards, because AI project is still a project, and all projects have goals. So some kind of problems, that they need to solve, some kind of KPIs, some kind of stuff that they need to solve in order to bring some value. And this can be like simply increasing some revenue, right? So adding new features to application, or maybe optimizing some costs in order to simply increase the revenue of the product or the company. It can be if you're working with some NGOs or some other kind of organizations, it can be like something reduce pain points. That's also a thing. So basically, you can either increase some revenue, right, increase the profit, or you can do so. When you're working with NGOs, you're also solving some problems. You are trying to help someone in some ways. But the thing is, for example, one project that we had was actually about delivering predicting some predicting some rains, like heavy rains, before they actually fall, because so that people can evacuate. And for that, the goal was to actually save lives, right, or so that the people are not endangered. Nobody was actually, obviously, nobody was like directly profiting from that, but that's also a goal. Building an army of agents with whatever is the coolest framework right now by itself, that is not a goal, right? So as mentioned, the tech is important, but you always need to think about what you are working towards. And let's take a little step back in time. I'll walk you through a case study when we were working on a project that was actually building an application that was supporting brain diagnostics. So, this is an image from the MRI scan of the brain, right? So everyone has one. Well, you might think with some people, when you're talking to them, you might think that they don't have it, but believe me, pretty much everyone in the world has one. If you go into this big scan, right, the doctors put you in for like a half of hour there, and afterwards, when you are out, you're receiving scans similar to that. And the goal of this project was to simply, pick some interesting information automatically, so that the doctors, can diagnose better, can see some important anomalies with, they are highlighted for them. They do not have to go through that in case they missed something, right? And, that was the time when convolutional networks were a big thing. So especially for segmentation. So, mapping different structures, in the input you have pixels, raw pixels. In the output you have pixels that are assigned to different classes. And, we thought that, okay, so let's do that. That would definitely be if that was the latest thing that was like really achievable with technology. That was a breakthrough. And we thought that why not? We'll map all of this. We'll essentially build an algorithm that will map all this brain into specific structure, give the doctors the measurement. This will surely be helpful for them. And it took us a couple of months, right? Because frankly, in the end, we ended with something like that, right? So our output was very similar. We segmented the whole brain with our algorithm. We had the measurements. And we are pretty proud of that. So we are showing that to the doctors. Unfortunately, the doctor's reaction was something like that. So not really impressed, in a sense that, well, they told us that it was pretty cool, right? Pretty interesting from a research standpoint and so on. But in like daily practice, that's not something that they would ever use. So the lesson from that, as simple as it might sound, always align with your users, right? What they actually need, because you might think that one thing would be interesting, or in our case, well, it wasn't like we, invented this segmentation and didn't consult it with like any doctor, because we consulted with some doctors before, but they were clearly the outliers, right? So they were like really interested in research and so on. But like when we went to the hospitals, as said, the doctors were not impressed. So always regularly align with your users. Okay, so after a couple of interviews, we ended up with narrowing the scope, right? So we asked them, a cohort of like 10, 20 doctors, okay, so what would you like to see, right? And after a couple of iterations, they're like, okay, aneurysms would be like very interesting. So for those that are not aware, so this here you can see the brain vessels, right? So as mentioned, everyone should have brain, and in this brain you have also blood vessels. And the aneurysm is an irregularity, right? So anomaly that in some cases some anomalies appear and the blood is not flowing smoothly. And the problem with that is that there's a risk that this aneurysm can rupture. If this ruptures, then you have a stroke. And the stroke can be deadly, right? So you can even die, you can end up disabled. So this is something that was very small, but this is also something that that was easy to miss. They told us that, okay, this is very important, we would like to see that. So now we had the input. We started working on that. The problem with aneurysms are that those are very small, right? So basically, it's if you see the whole, if you look at the whole scan, like 3D scan, you can see we have one here, and this one is really big, right? To be honest, usually there are a couple of millimeters at most. Essentially, if you compare it to this standard aneurysm ratio to the whole head volume, is like 1 to 10,000 or something like that. So it is like you would go to the out of the whole Poland, right, which has like 40 million people. This were like, okay, you are picking random person, random number, and they are like at this particular wedding, right, for example. So basically very easy to miss and very easy to achieve very good performance on, right? Because if you look at the metric wise, it was very easy to like achieve accuracy of 99%, 0.999 and so on. You are simply saying that for every voxel the aneurysm is not there, right? But obviously this is useless, right? So that's not what you did. Obviously there are better metrics for that from machine learning standpoint. Like for segmentation there's dice score, and actually whole family of dice scores that show that better. And after so we essentially reported that, right? We achieved state of the art as far as those machine learning metrics go. But when you're showing those to the doctors, they are also like, well, okay, this dice score is nice, but it gives me nothing, right? So this is also something that people are often doing, like machine learning engineers, and this is a lesson that for them this is something that I also give them, because people are focusing on the machine learning metrics, which are obviously like important, but in the end those are not they are not exactly something that translates to end users, right? Obviously there are some cases when they're perfectly fine, but here that wasn't the case. So okay, we tried with detection metrics, right? So like recall and false positive rate. So how many aneurysms we actually detected as an object correctly, and how many we detected falsely within the whole per scan per brain. And okay, this was definitely better, right? Still, it was not enough, right? Because when we talked with the doctors, it took us a couple of other iterations in order to end up with what they would actually also need to see, want to see. And the answer for that was that, okay, we want to detect those aneurysms, we want them, see them visibly, but what matters for us is the volume, right? The shape, right? So different shape metrics, how tortuosity of that is, right? How curve is that? Essentially, when it lies in when this aneurysm lies compared to the normal vessel, because based on that they can actually predict a risk score of aneurysm rupturing, right? And they know if they should treat it or if they can leave it as is. And after that, when we actually did all of the segmentation metrics, well, not segmentation, those custom, geometry metrics, geometry measurements for the aneurysm, we needed to implement everything like that from scratch, right? So working with doctors, working with on custom formulas for a couple of weeks, in order to get that right. But only after that they were happy. So the lesson from that is, like, choose your metrics wisely. Because the machine learning ones, they are usually not while useful for you for the development, they are not often not something that the end user cares about, right? You always need to check that. And this project is actually a very good example, right? I would say, but because I did you a short, like version, but this was something that was taking like this whole project took like a couple of years, right? And basically, while we had the segmentation metrics, there was like no commercial interest, right? The project was kind of stalled, and only after we did this user alignment, did this shift, actually get this all metrics, hospitals and doctors started to want to use that, and this company was actually later acquired for 8 million, right? So as trivial as it might sound, right? Because, well, sounds obvious, right? Talk to the users, right? Get what they want. This is pretty easy to miss, right? And it's pretty crucial. From like the retrospective, this user alignment, this all in these interviews, we could get them much faster done right much faster. So another thing, is this one. Probably you also already everybody knows Netflix, right? Probably quite a lot of you are either using that, or probably are you using some other VODs, right? If not, then you still definitely you know the drill. You know what's the idea behind it. So and probably most of you are aware. If not, then you will learn that for every like VOD platform, whether it's Netflix, whether it's HBO, whether it's Amazon Prime, for every user, they are tracking what videos, series, and so on that the user actually watched, and based on that, they do recommendations, right? So there's a recommendation engine underneath. So if I were to like visit the Netflix right now, they might give me like a suggestion of Lord of the Rings, right? Which would be a pretty good suggestion. I wouldn't watch it because they don't have extended version, but still, that's a very good good thing. And back in the days, Netflix actually was working quite a lot on their recommendation engine. To the point that back in, I don't know, like 28, 29, they were holding competitions, right? When they open source some of the data, and they actually promised pretty big prizes, like $1 million even, to the teams that will beat the Netflix baseline performance, right? But at least that like couple of percentage points. And these competitions, there were many teams that applied. They were working on those algorithms for weeks, and a couple of them actually beat Netflix by a large margin, right? Think of the best one, as you can see, they're like better than like 10% points over the Netflix baseline. So, well, it sounds very impressive, right? Does someone know or want to guess what Netflix did with this new improved algorithm? Okay. Purchase those teams, used it. Yeah, so the answer is quite the opposite. They haven't used it at all. They scrapped it. Simply, they did a whole evaluation, but they essentially evaluated all of those new methods, but the learning from that, the evaluation that they did, the outcome of that is that, okay, there was additional accuracy, right? But it did not justify the engineering effort to bring this to production environment. So all those algorithms out there, they were like very complicated ensembles, right, or complicated algorithms that were simply too costly to run in the production. So another lesson, you might also always consider what is the cost, of running, cost of the algorithm running, right? So sometimes the simpler solutions are better or more feasible, because they are less costly. They are easy. If they are simpler, it's also usually easier to maintain. Because in that case, Netflix simply crashed it. And for many cases, like right now with LLMs, that's also the case, that some people are starting, they are throwing a very different, they are throwing like the very heavy LLM models, right, that are simply costly, right? And it turns out that, okay, it works well, but for example, but you need like Opus, the strongest version to what was out there. But it's simply the cost of those tokens are simply too much. That the case that we are seeing quite often right now. And I can see that we have a couple of comments on that. So one from Mikhailo, that perhaps better accuracy couldn't yield additional revenue, right? Recommend not what the user wants to watch, but what needs to be sold. That's a very good very good take, right? So I don't know the details behind it. It's not like Netflix, publish the whole business analysis, but that may very well be the case, right? And you also need to always think about that. Another thing is that another comment from Roberto, that tokens are rising. The cost of using the AI with the increasing context windows. Will it be better option than connecting to whether using open source models and in-house LLMs might be a better option than connecting commercial closed systems. That one is good for this particular case, in a sense that it illustrates the issue here, right? So the answer would be that this depends, right? So it might be that with time, people will be moving to open source, like open weight models. On the other hand, as Shubham mentioned in the chat, right, for the small, if we are talking about the very big models, right, the powerful, the open weight ones, they require heavy compute, right? So it might be possible for some cases, right? For example, if you are good, if your problem is simple enough to run like, I don't know, like Gemma or like 27 billion parameter models, which actually you can run on like more beefy GPU, like with 24 gigabytes of RAM. Then if you are performing if the problem is simple enough to solve with that model, that's probably the costs will be much better if you are not doing it by using the commercial models. On the other hand, it also depends on the patterns of the traffic, right? But because it might be, if you are like really processing something like 24/7, then it's much different if you just need to process something like once in a while, right? So that really depends, right? It's really depends. Also, it depends on the whole architecture of the solution, because as we can see, there's already a comment that, okay, for some small parameters models, they don't have the too much knowledge ingrained, right, learned, and that's also true, right? But in many cases, small models are fine if you are, like connecting them to RAG, your sources, like different tools. But for many, they are not enough, right? So I will move further from that, but the answer for this one is usual. Unfortunately, the usual answer in the IT, right, in the architecture, that it depends. So again, another aspect that is very often overlooked in many of the IT projects is something that I would say human maintenance, right? So obviously, you need to here probably, because we are in a like data or AI webinar, people are like rather optimistic towards the AI, right? But if you look at the studies, that's not really the case often, right? So here, obviously, this is the from this was done as like 2025, right, on data going up to 24. But essentially, across the countries, the consensus was pretty much 50-50, that people were agreeing with the statement that there's more pros than cons of utilizing AI, right? So another thing is that, and nowadays is even worse, right? People are often, like afraid, okay, because there's like the narrative from the big labs that okay, AI will replace everyone, it's coming for your job. So another thing that you also need to take in like actual projects is to educate the people that okay, it's not something scary. This is how it will help you. Show them the product, how they will benefit from that, so that educate them that they are not afraid. Because otherwise, I have a case which is well, actually not mine, but colleagues of mine from the university. They had a case when they were automating a magazine, right? Automating like the warehouse. Sorry, the warehouse is the word, and in the pilot, in the like smaller prototype version of which they had at the university, everything was working great. Then they actually rolled it into actual warehouse, and they get get the feedback from the company that okay, everything is failing, right? That the robots that they have, they are constantly malfunctioning, constantly tripping and stuff like that. And they were like, okay, but it shouldn't be the case, right? So they tried to debug that for quite a while. They couldn't get into why those algorithms perform such differently, why those robots are actually malfunction that frequently. And the answer for that was only found after they installed the cameras to observe those robots live. And it turned out that the warehouse workers, they were like they were sabotaging the robots, right? So like pushing them, putting stuff in their way, and later after some kind of error, they were clearing the obstacles so that it wasn't visible, stuff like that. Simply because, as it turns out later, they were afraid of replacement. So this is as far as it may seem. This is as it may seem, it's not. It's actually the case that it's often that might happen, right? So you need to have the users on your side, right? Convince them that okay, they will benefit, they won't be replaced, or if they will be replaced, well, okay, they prepare them for it, right? Because even if you don't do that, then the competition will. So. Okay. Yeah. So convince the users they will be augmented, not replaced. Another thing, data, right? So as you know, essentially all machine learning algorithms, whether those are LLMs or traditional ones, they need the data to be trained on. Data is always stated to be a new kind of oil, right? So. But the data is also always messy. So one thing that you also always need to take care of is to ensure the quality, so that everything, so that the data is actually consistent, is actually accurate. there is no missing data points, there is no missing features, and also that you understand everything. So because the universal rule, data is always messy, and it's not always easy to debug to debug that, right? If there are some issues with the data. So another point will be about utilizing the domain experts, because if you will look at the screen, this is actually a pretty easy one, right? You're doing some analytics, you are looking at the share of revenue from the e-commerce, and you can see that there's like 2 peaks there. So there are 2 peaks there, and if you look at that, probably everybody here would guess what are those points. This is the November to December, right? There are 2 huge peaks before the holidays, and those 2 are. I didn't ask, but probably everybody would sooner or later. No, that's not for May. That's November, right? So before Christmas, you have Black Friday, you have Cyber Monday, and this is something that maybe not it wasn't obvious to everyone right from the beginning, but this is something that is a common knowledge. It would sooner or later you would actually came up with idea where did those 2 came from, right? But here there's actually another this is a spectrogram, so the signal coming from the sensors at the bottom of the seafloor, right, from one of the projects that our local university was doing. And the goal of that project was to monitor the seafloor, to detect those signals, to detect the I'm missing the word here. Let me to actually detect the group of fishes swimming by. And this group of fishes is essentially a very big group. It's something like that, like you can see here. If you actually zoom it out, there is some small point that one can see, right? But suddenly, another thing that you can see here is here, right? So this is huge. This is like 10 times bigger than anything that they saw before, right? So they were thinking, what might be the cause of that, right? And they checked if there is because there is no way that there's such a large group of fish in that region. It wouldn't be a whale, right? They couldn't came up with idea of what this could be, right? So they came to a conclusion that it is either a sensor malfunction, right, or it is either a sensor malfunction, or it is basically some error in their formulas, right? So they checked their code twice, right? So they checked the code twice. Unfortunately, there was no error there, right? So the conclusion that they came to was that, something failed, we need to replace the sensors. The problem is that, those sensors were at the bottom of the sea, right? And it was very costly. That's why they triple checked everything before coming to that conclusion, because that would be like hundreds of thousands of euros to swim to the bottom of the sea, replace everything. But that was the only idea that was their own last conclusion. So they actually called the research center in Norway that, hey guys, we'll need to replace the stuff soon, right? When can we schedule that? And at the research centers, they were like, that's pretty costly. Why would we do that, right? So they explained that on this day there was the sensors malfunctioned, and it seems like everything is broken. we simply need to do that. And they're like, okay, wait a couple of minutes, I will check something. So they were called back in like 15 minutes, and the guys told them that, oh, don't worry, right? So that signal, that's like that's a submarine, right? Because there were military exercises there. This is where this is coming from. Your sensors are fine. You don't have to worry, right? Exactly. This was like nothing that was public, right? There were like secret, there were like military operations, military training. So it's not something that is advertised, but that was the reason, right? The people at the research center, they know it, right? Because they are there, they are in the loop, and simply the lesson from that is, well, utilize the domain experts, right? You can also always work on the data that you received, but understanding the nuances of that usually falls to some business or domain experts. A couple of other things, right? Which I added today for you. Thinking about the projects is another lesson. Another advice would be to be a squirrel, right? So as you know, the squirrels are gathering, peanuts to the point that they even have too much, and they forgot when they store them. So the lesson is, do the same with data, right? Because storage nowadays is cheap, right? So if you were to store like 1 terabyte of data today, it is like $20 per month. So it's nothing, right? It's very cheap. While the opposite, if you don't do that, then often what we are seeing is that we are supposed to start the project. We are asking, okay, guys, in order to solve this problem that you want to solve, we would need this data, right? Do you have it? And they are like, oh no, we didn't think to store it. We'll have to wait like half a year before we can actually start. So store everything, because you never know when it could be useful, and the alternative is simply too costly. Obviously, do it efficiently, right? So without duplication, do it versioned, right? So this is actually from one of the projects that we came to that was already running, and we are bring on board to actually help to rescue that. And we essentially saw something like that, right? So data was versioned in directories, which was like copy of copy of copy. And the latest version was even inside one of those directories, not even one from that, right? But they were nested. So don't be like that. Don't be like that. So this is the bad example of versioning. This is the good one, right? So store it in Git, store everything like configuration, code, data pointers, because basically, yes, as there is a comment, as in any scientific research, right? If your work involved any writing, editing software scripts, whatever, then you should be using version control, right? So because Git remembers. And that goes beyond the code, right? That goes for data, the cloud configuration, hyperparameters, ML models, right? So obviously stuff like MLflow, that's also a given. That's also something that you should be a good citizen and simply, for either your team or either yourself from the future, store every results of the experiments. Another thing, deliver and file fast. So this one is pretty simple, right? But nowadays, especially with like AI agents and all the LLMs for writing the code, it's very easy to have something, right? We are not saying about the final product, but what you can see here, probably if you are like working with data, some people will already recognize it. So this is Streamlit. The library in Python, which allows you to very simply do a put an interface on top of some data do a very simple web application. And doing even something like that, deploying something like that, will allow you to show it to the user and get their feedback, right? They will tell you, it doesn't have to be like perfect from the beginning, but they will tell you the direction that, okay, this sucks, this sounds really useful, maybe we need something else. Okay, another thing, stand on the shoulders of the giants, right? So, essentially, you can write your own libraries, you can write your own code, and right now it's very tempting with like fast code generation. But, for pretty much anything, whether it's platforms, whether it's something for the data, whether it's something for modeling, there's probably already a library for that. So don't reinvent the wheel. Use the ecosystem that's already out there. Simple as that. This obviously includes the AI usage, right? So nowadays, as mentioned, it's very easy to produce something very fast, right? And you should take advantage of it. So there are some purists, right, that they are pretty against any kind of agents, any kind of AI utilization in coding. But simply the answer is that the situation is that either you will use it or everyone else will be faster than you. So simply make peace with that, right? It's not gonna change. You need to use that. Obviously, be sure to control that, right? Because otherwise, you might be ending with like the guy here, right? So build a vibe coded app, right? Brag that people are paying for that, but well, it was purely vibe coded. So there's like it ended within like 5 days, right? So guy didn't know what to do, what was the code, what is the code actually doing, right? Didn't evaluate it in any way. Long story short, the app ended in like 5 days, right after all his keys were hijacked and stuff. People were bypassing the subscriptions and so on. So the fact that it's very easy to create something does not mean that you don't have to control the quality. But still, as mentioned, right, nowadays, and again, underlining that it's worth using those tools, right? Because even in our internal benchmarks, right, and we have some cases when we simply benchmark that, okay, something like that took 2 months before, now it takes 2 weeks. Obviously, this needs people that know what they are doing, like seniors and so on, but the point stands. So we haven't covered a couple of things, right? So, like legal and compliance, how to deal with biases in data, scaling the solutions in the cloud. There's much more, right? But the point, as you saw, quite a lot of that was maybe excluding the last points were actually about nothing really like technical, right? Like strictly technical, but rather how to manage the project well, right? Be oriented for the goals. So remember, the technology, it is just a tool, right? You need to look at the bigger picture and combine your data. Combine the data, combine your technical expertise, but focus on the value, focus on the users, focus on proper project management, and then you got this, right? Then you won't be in this group of 80% teams that are failing. I won't promise you that you will be always that things will always work out, right? This one is not. I'm not claiming, but the ratio will fall to significantly to maybe something like 30, 40. There are also always factors that that you can't take out of the equation, right? Phase will always happen, but just applying those principles, you will see that your projects will be will be going much smoother and have a higher success rate. Okay, so yeah, that would be it from me. I will look into the chat, and if you can bump the questions that are current, that would be great. But other than that, hope you guys for listening. Here is the QR code for my LinkedIn if someone wants to like connect, follow, ask about something, but they are shy right now in the chat. But yeah, thanks, and let's move to the questions.
Yes, let's move to the questions. And also, if somebody wants to actually talk to us, just put raise hand button. I'll unmute you so you can talk to us. Other than this, please use chat. Please use the button to send to everyone so everyone can see your question and, be in the context of what we are talking about. But Michal, I will ask you to read out the question before you answer so we can have the question in the video as well. Thank you.
So I'm going from the bottom to the top. So the first question will be from Roberto. So is important to identify the right problem, have the right people, and communicate effectively? Yeah, that's I would say is pretty like those are probably the most important points, right, from this presentation, right? So you need to solve the right problem. You need to like solve them. You need the definition of solving, right? So if you go back to this like brain case study, we were solving the problem, but even with the same technology, it wasn't like the problem that the doctors wanted us to kind of solve. It needed some tweaks, right? So you need to establish what does it mean to be solved, what do the end users and problem is actually, and how what is the definition of solving that. Communication effectively as well, right? So nowadays it's probably more important than ever, right? I would say, because you can develop much faster. So you also need to. So it's also very easy to like stray back from the right path very fast, right? So requirements gathering, doing a business analysis. I believe that like every developer should be able to do it nowadays. Okay. Moving on. So question. We have fast development iteration. What about faster testing? Unit testing is out of scope. AI writing pointing towards functional UI testing. How that can be faster? Yeah. So that's a tricky question. I don't have the like definite answer for that, because this is something that I see quite a lot of companies and ourselves struggling with as well. So we are still working on that. I don't have the like definite answer, but the generation of code is very very fast. But the testing, even reviewing the code, it's the effort here stay the same, right? So what I can give as something that we found useful, right, in solving that. So you already mentioned the testing, right? So like unit testing, have a guardrails, right, for whatever agents you are using so that they generate the correct ones, right? So put the right harness on top of that. As for the UI testing, there's also something that you can generate, but or do with the agents, but will it be like deterministic? Will it be always good? That's not something that I would say, but I saw people do that, and that's also a thing. But in many cases, like for example, we have a partner company that is like the game development. So because when they are testing, they have a ratio for like one developer that is pushing the code like daily, and for this person there's like three quality assurance people that are doing the tests. So yeah, unfortunately, that's the problem. That's the bottleneck right now. The direction that I would be going in is to make the code as with the harness, with the checks, try to generate something that is as good as possible, like even at the more like token cost, even if that's slower, but try to, like generate less slop, generate something of higher quality, and putting the right guardrails harness for that. Okay, let's move up. Okay, do anyone use DVC as a version control for big size artifacts in real life projects? I would say that depends, in a sense that depends on what do we think big size artifacts are, right? I would say the bigger problem with DVC would be like many objects as opposed to big objects. But the point stands, right, that it is limited for like vast data. And my point would be that you don't have to use like exactly DVC. There are other tools. You can have something, but you can also have something on your own in a sense. I'm not saying about writing another tool, but organize your data in a lake or in the ETL pipelines in a way that have the same that follow the same principles as DVC, right? So this actually I had a demo even like today with one company that we are building. Then when we are building with a medtech company, right? So it is pretty regulated. You need to trace when you're training algorithm. You need to trace it back to you need to have a trace back to every like object that goes into a training data set. And there are a couple of limitations that why we are not using DVC there. But the principles of DVC we follow them, right? So in a sense that every object has a cache, right? If there is a change, right, of the code or like the data, then essentially like we recompute those caches. We have the trigger mechanism. It's in the pipeline, right? Not in it's in our logic. It's not in like off-the-shelf tool. But yeah, that's the answer that I would give, right? That even if the tool itself is not good, that the patterns behind that are, right? So okay, let's move up. Okay, the next question that I see, or the comment, is from Serhi. And he says that I can see 2 points, right? So one, software engineers who say that AI writes really bad code. And the second, from business, they really believe in spec-driven, where engineers becomes architects, which helps save money. What do you think about that? Yeah, so I believe that I kind of addressed it at the end, right? So this question might be a little outdated. So I believe that both sides need to meet somewhere in the middle, right? Because there are developers that are really like hating the AI, that's saying that okay, it generates crap. I'm writing the better code, and to be honest, like 2 years, even 1 year ago, I would probably even agree, right? But nowadays, the model simply improved too much that okay. If you are using them correctly, they generate something that might not be perfect, might need a couple of iterations, but the what's important is that it speeds up the process. On the other hand, there's business, and the problems that I have, for example, is that I'm talking to business that they vibe coded something, right? Because they saw some video, right, and now they are they like vibe coded something that is running on the local host that has no security whatsoever. That is actually a static website, but hey, they built an app, and they are saying that okay, now they don't need developers at all, right, or engineers at all, and or basically like objecting to every estimate, right? Because they did it right in a day. So why you are saying that production version that needs to serve the scale of tens of thousands of users and be compliant with regulations, while you're saying that it will take you half month, right? If I have something, so that's the problem, right now. but generally you need to meet in the middle, right? So the answer is that, okay, I wouldn't say that the AI generated code right now is like something that you can just put out to production. Definitely not. Definitely you should use that to develop faster, but still the quality control is very important. The currently is the problem that development is faster than the quality, right? Capacity. Okay, scrolling further. Yeah, I don't know if I can see some past questions, so I will scroll down back. I will scroll back down. If I miss
Yes, we
something,
have some new
yeah, we
questions.
have some new questions, so I will take new questions. But guys, if I miss something from the older ones, please paste them once again. Uh,
We have some new questions. So the one that you haven't answered is Serhi, what are the bad skills? And then all the way down.
yeah. So, what are the bad skills? I don't understand this one, right? So, what do you mean like bad skills? What do you mean by that? Sorry, if you can clarify that, I will move to.
There are more questions from Serhi very at the bottom.
Mhm.
Maybe that's actually the clarification. What are metrics to select the best model
Mhm.
and maybe the best skills? That's what he meant as well. Yeah, the best skills. What are the best skills? Then we have what are metrics to select the best model and where we go to small specific models or to big models.
Yeah. So I will take those. So, what are the metrics to select the best models? So I would say that's a wrong. Maybe I would phrase this question differently because like metrics to select the best model, they are dependent on the business problems, right? So they are not like universal that, hey, you should always use this metric and this will tell you that this is the best for the solution, right? So you also always need to take into account what problems they need to solve, like business wise, and then adjust metric to it, and then essentially evaluate the models, the algorithm that you are saying against that metric, right? Whether it's from the like using some hyperparameter tuning or some grid search, but basically the point is define the metric first, then simply do experiments. Where we go to small specific models or to big models, that's also depend. Sorry for that, right? But the answer also is that it depends. But to give you a couple of like general ideas, is that because I assume that you are thinking about like big and small, like LLMs, like language models. So here I would answer that. Uh, Usual rule that I would follow is that very well, if you need something that is very hard problem, like you need very capable models, obviously then you go for the big one, right? Because the small ones might be not good enough to actually solve this, or it might be that you will be spending quite a lot of engineering time in order to build something that you could in order to improve or put the guardrails over the small models that you could simply solve by utilizing the big model. So that's like one thing to think about. The other thing is also like what is your stage of development, right? So if you just want to prove some idea, maybe to business, maybe test whether they would like something, it's again, right? Even if like smaller models, a chain of smaller models would be good enough to solve this problem, it might be that it's always worth to check first whether you can solve it with the bigger one, right? And then once you confirm the hypothesis that okay, this is the problem that you want to solve from like business perspective, then you can like optimize, go to the smaller models, go to the and build some like more complicated chain, which is more cost efficient, for example. So that would be like the couple of guidelines there, but But unfortunately, it always needs some experimentation. And even the big models themselves or small models themselves, they vary quite a lot in a sense that some models can perform very good for a problem, while it might very well turn out that for whatever reason, the model that is theoretically worse in capacity for your specific model is simply better than something that is supposedly bigger, right? So another point is always around the evaluation. Okay, moving forward. So we had one question from Yaroslav. Could we bet on AI or real human data, as we have the problems of hallucinations, LM, changing real data versus data in models, etc. Could we bet on AI or real human data, as we have the problem? I'm not exactly sure what are you concerned with. So if you could clarify that one, because if you can bet on human, yeah, maybe if you can just try to phrase it a little differently, I will take it in a moment. So question from Mikhailo in the meantime. So having a deterministic output is a pain point of building systems around LLM. That's true. Quite often it becomes very hard to validate and test the response depending on the input data. So that's not really a question, but definitely a true statement, right? In a sense that deterministic output is a little tricky. So because you can actually get a deterministic output from the LLMs, but only the ones that you self-host, and you sacrifice the batch size. So essentially the costs are usually too big. But the point of that is that even if you are not deterministic, then you can try to circumvent this problem in actual deployments. Usually the thing, so two things that might be handy in that case is either, obviously, it depends on the project, but often when there's a need, right, for something being deterministic or the output being very good or predictable, then often it is for a reason. And in similar systems, you already need to maybe have a human review, right? So that's like all the medicine, like or healthcare cases that, well, maybe not all, but quite a lot of them is that, okay, we are generating something, right? We obviously need the output to be the best, but still in the very end, someone needs to sign that off, right? So this like design and having human in the loop can mitigate the problem here. Another thing is also to have this like traceability. So one of the cases, if business is pushing us very hard for like the deterministic output, often we found out that, well, they are fine with not deterministic output, but they need to know where it came from, right? So you need to give them the reasoning chain. You need to give them the whole audit trail that, okay, this is not deterministic, but they can also check why the model performed this decision and what particular data. Okay. For someone wanting to seriously train an AI, what hard and soft skill you recommend should be developed? And it's good to constantly publish all your practices and projects to GitHub. So in terms of the hard, it's hard skills. Definitely, I would look, like above, AI. I would look above the actual models, right? So I would think about, because ultimately, AI is just a piece of of some system, of some application, right? So if you are doing something, if you are training, right, you are doing some kind of algorithm. I don't know, like what might be a good example. So like detecting, for example, some animals from the from the video, right? Pretty simple, pretty something that can be done. So you can have it in like a notebook, like Jupyter one or some Python code. And if you are training if you and that's like, okay, you have the algorithm, but that's just a piece of the system, right? What I would train for is, okay, I have this model. Now think about, okay, if this were to be used by some real user, what I would need to do with that, right? And maybe try to like develop some simple interface for that. Try to host it on some public cloud, for example. So yeah, I'm just giving a little advice in a sense. If you think, I don't know if you are like switching to AI, or if you are like thinking about the first job, right? But the still the advice holds true in a sense that think about the AI itself, because you always need the data to supply to it. You also need this to be deployed. You need this hosting and so on. And if you're like applying for like the junior positions or first roles, if I'm recruiting, for example, and you actually did an application that, okay, I can see the demo of, it does not have to, the algorithm does not have to be perfect, right? But if you actually deploy that, that's much more valuable, like having one application end to end than like three different like algorithms, notebooks whatsoever. So